Hi, this is Lakshmi Kantiwari. In this lesson, I am going to teach you about a step forward, step backward and the exhaustive feature selection by using a wrapper method. So in a previous videos, if you haven't watched, you can go ahead at my channel KGP Talkie and you can watch the feature selection using a filtering method. So I have taught there the many feature selection techniques by using a filtering methods. The filtering methods were not very accurate, although they were pretty much faster than other method techniques. But in this lesson, I'm going to teach you the feature selection using a wrapper method. So in this lesson, first I'll talk about the wrapper methods and its type of the wrapper methods, like a forward step selection, backward step selection, and the exhaustive feature selection. Then I'll be using mlxtend library to implement these wrapper methods, feature selection using a wrapper methods. You can go ahead and learn more about the mlxtend library from this given link. Then I'll talk about a little about the mlxtend library, how it works. Then after that, first I'll talk about the step forward feature selections, where I'll be working with the wine dataset, and then I'll be showing you that how you can work with the step forward feature selections and how the accuracy changes as you select the or as algorithm selects the features. And then after the forward step selections, then I'll teach you about the step backward selection. Although there is not pretty much difference than the forward selection, there is just one line of the code which changes. Okay, this is the forward is equal to the false. That's when it now becomes the backward step selection. And then I'll tell you about the what is the difference between the step backward and the forward selection. After that, I'll tell you about the exhaustive feature selection. So the exhaustive feature selection is the most expensive feature selection techniques. While training these data sets, it might take the hours or few days if you have a large feature set. So here we have a small feature sets. That's why it is not taking pretty much time. Otherwise, it might take a lot of the time. So this is the most expensive features selection technique. That is the exhaustive feature selection. And with the exhaustive feature selection, I'll show you how we can get the best accuracy. The best accuracy is the 1. So in this, it has produced the best result, which is 1, and those the feature names are here. Although the exhaustive feature selection is the complex one while the selecting, but this is the best one to select. And then I'll show you the plot how you can see how accuracy is changing throughout the number of feature step actually. So there are total 2002 times, so it will iterate over the features. Okay, so without wasting the time, let's go ahead and start this lesson. So in wrapper method, we try to use a subset of features and train a model using them. Based on the inferences that we draw from a previous model, we decide to add or remove features from your subset. That's mean the feature subset. The problem is essentially reduced to a search problem. And these methods are usually computationally very expensive. Moreover, we can say the wrapper method uses the combination of variables to determine the predictive power of the model. It also finds the best combination of the variable. But one thing you need to remember, it is computationally expensive than the filter method. Although it is more efficient, I mean in the term of the accuracy, than the filter method. And it is not recommended on higher number of features where it will make the huge the combination of the feature, and practically that would be a little or a very difficult to implement. And the wrapper methods are based on the greedy search algorithm, as they evaluate all possible combination of features and select the combination that produces the best result for a specific machine learning algorithm. That means, as I said here, for a specific machine learning algorithm. So how it do? In filtering methods, we had not included the machine learning algorithm while selecting the features. But in the wrapper method, we include the machine learning algorithms while selecting the features. The downside of this approach is that testing the all possible combination of the feature can be computationally very expensive, particularly if the feature set is very large. It is divided into the 3 parts. The first method is the step forward selection, and the another one is the step backward selection, and the third one is the exhaustive feature selection. Okay, so now let's go ahead and first learn what is the forward step selection, or you can say the step forward selection. In the first phase of this step forward selection feature process, the performance of classifier is evaluated on each of these features particularly, and then the highest performing features are selected. And in then second step, the first feature is tried in the combination with all other the features, and then the combination of the two features that yield the best possible performance is selected. And then this process continues until we reaches our desired number of features or our desired the performance of the model. And similarly, in backward step selection, as the name suggests here, it do the exact opposite as we do into a step forward selection. In the first step of the backward feature selection, one feature is removed in a round robin fashion from the feature set, and then the performance of classifier is evaluated, and this process goes on, and we keep removing the one features which is the least important or the least performing in the feature space, and it keeps on until we reaches a desired performance or desired accuracy or desired number of feature set. And then finally the third type, we have exhaustive feature selection. In the exhaustive feature selection, the performance of a machine learning algorithm is evaluated against all possible combination of the features in the feature set. The feature subset that yields the best performance is selected. The exhaustive search algorithm is the most greedy algorithm of all the wrapper method, since it tries all the combination of features and selects the best one. The downside of the exhaustive feature selection is that it can be slower. In fact, it is slower compared to the step forward and step backward method, since it evaluates all feature combination. Let's suppose that if your model have n feature, or your the data have n features, then it evaluates 2 power n minus 1 the feature set. For example, if your model have 10 feature space, then it will run at least 123 times, because 2 power n, that's the 2 power 10 minus 1 is 1023. Okay, now you see only you have 10 features, but your model will run for at least 1023 times. So this is the most computationally expensive method, exhaustive feature selection. Okay, perfect. Now the things has been made easy by using this library mlxtend. You can go ahead at this link and you can know more about the mlxtend library. What you need to do, you need to first install this library. You can go ahead in the installation section. There you see you need to do the first pip install mlxtend, and what you need to do, you can install this library from inside the Jupyter notebook itself. You need to write here, okay, this line of the code in your Jupyter notebook cell and then run it. I have already installed it, that's why it will not reinstall it again. Otherwise, if you don't have it, it will install in your computer. Okay, perfect. Now let's understand how this mlxtend library works. Okay, so the sequential feature selection, this library have a API. Okay, API there you can go ahead here, the feature selection. So in this, it has sequential feature selector. Inside this sequential feature selector, we can select the feature sequentially. So this library has implemented all the things which we had seen in this presentation previously, and it has made our task very easy. So this basically works on the greedy search algorithm that are used to reduce the initial d dimension feature space to the k dimension feature space, where k is less than d. The motivation behind the feature selection algorithm is to automatically select a subset of the feature that is the most relevant to the problem. And the goal of the feature selection is the twofold. We want to improve the computational efficiency and reduce the generalization error of the model by removing the irrelevant features. In a nutshell, sequential feature selection removes or add one feature. Sequential feature selection algorithm remove or add one feature at the time based on the classifier performance until a feature subset of the desired size k is reached. There are 4 different flavors for sequential feature selection algorithms available into a sequential feature selector, and these are the 4 algorithms which is available into a mlxtend package. So in mlxtend package we have these 4, although in this lesson we are going to learn these 4 sequential feature selector, and then finally we will learn about exhaustive feature selection. Perfect. Now let's go ahead, first learn how we can implement the step forward feature selection. And for the step forward feature selections, we are going to first import some necessary libraries, and those necessary libraries are numpy as np, pandas as a pd, seaborn as sns, matplotlib.pyplot as a plt. And then I'm gonna import train test split, random forest regressor, random forest classifier, ROC AOC score, sequential feature selector as SFS from the mlxtend, and other functions from the sklearn library. And after this I'm going to work on the wine dataset in this lesson. Perhaps this is the first time when I'm going to use the wine dataset in my throughout the machine learning lesson. In previous lessons I haven't used the wine dataset. You can load this wine dataset from the sklearn dataset directory, and then I'm also going to use the standard scaler, okay, for a pre-processing. Although we will be using here the tree based algorithm, so the tree based algorithm doesn't depends on the normalization or standardization of the data. Okay, perfect. Now let's go ahead, the first load the wine dataset, and there we can write there the data is equal to the load wine. Okay, and then here we have data.keys. Okay, data target names, descriptions, and the feature names, these are the keys are available in the load wine dataset. Now let's go ahead and see the description of this load wine dataset that we can get from the data.dscr, and here is the description of the wine dataset. In this we have a total 178 instances, and there are 13 numeric the features, and these features will be used to predict the wine type, and there are 3 classes to predict. That means this is the multi-class problem. In the multi-class problem we have 3 classes of wine which we need to predict based on these 13 features. Okay, and this is the summary of those features, and now you can see here the mean of these features are varying pretty much. If we don't use the tree based algorithm, then we need to bring these features on a same scale. That's mean we need to do the standardization or normalization. Otherwise, if we are going to use a tree based algorithm like a random forest or decision tree, then we actually don't need to do standardization and the normalization, since tree based algorithms are very immune to the standardization and the normalization of the data. Okay, perfect. Now let's go ahead and get the data set into x and y vector. So in x vector we are going to take a feature set, that's the pd dot data frame, and then here we have a data dot data, and inside the y, that is the output, we are going to get the data dot target. Now let's go ahead and see the first few lines of the x. So there we have here the numeric data set. Then what we are going to do, we are going to first put the columns of x, okay, where I can put their data dot feature name. Perfect. Now let's go ahead and see if there is any null values present into the data set, which we can check from is null.sum. So there is no null values present into the data set. Now let's go ahead and do the train test split for this data set. then we need to get here x underscore train, and then x test is equal to y underscore train, y underscore test is equal to train test split, and there we have x y, and then we have here the test size is equal to 0.2, and then here we have random state is equal to the 0. Then here we have x train dot shape, and then here we have x underscore test dot shape. Now you see in the training data set we have 142 rows and 13 columns. Now our task in this lesson is to reduce the feature space and to find out the best combination of these feature set to predict the output. Okay, so this is our overall task in this lesson. Since it has just 13 features, for example, let's say you have a large number of the features, and there you need to reduce the training and the testing time, then definitely you need to select some feature set so that you can improve the accuracy and you can reduce the training and the testing time. And at those places, these feature selection techniques are gonna help pretty much to you. Now let's go ahead and start working for a forward feature selection. Okay. Step forward feature selection. That's the SFS. Now we are going to implement here the step forward feature selection, then step backward feature selection, and then exhaustive feature selection. So here it has SFS, step forward feature selection is equal to the sequential feature selection, SFS, and in that I'm gonna pass the random forest classifier to calculate the performance of the feature set, and the estimators in this I'm gonna pass 100, and then the random state which I'm gonna select the 0, so that you can pass here the same random state and you can get the same result as I am getting. And the number of jobs in this I'm gonna pass the -1, that's mean use all the available cores. Okay, and so this is the estimator which I'm gonna pass, although you can press shift and the double tap to get the detailed documentation for sequential feature selector, and here are the input parameter which it takes as an input. Okay, and then I'm gonna pass here the K feature. The K feature means the desired number of features which we want in this. Now in this I'm gonna pass, let's say the subset of the 6 features. That's mean it is gonna give me the 6 features, and then it will select the maximally performing subset of the 6 features. And then after this I'm gonna say here the forward is equal to the true. In this case it is going to make the forward feature selection. Okay, and then the floating, as I told you the earlier, it has 4 methods. One is the plain and another one is the floating. So the floating I'm gonna make a false, and then the verbose, that's mean we want the log while training the model, so we are gonna set the 2, and the scoring of the algorithm, the methods for the scoring which we are going to use for this, so that is we are going to pass here the accuracy, and the cross validation set we are gonna use 4 in this case, and the number of jobs, that's mean how many core can be used while selecting the features. The -1 says that use all the available core on this computer. And now I'm gonna fit this model on the X train data set which have originally 13 features. Now we want maximally performing 6 subsets of the feature, the subset of the 6 features. So it will now convert the 13 features to the 6 features, and then we have X train and then finally Y train. So here it is going to train this model using the backend, Talkie backend with the 4 concurrent workers, and that means it is using 4 cores in my computer, And since it is the step forward feature selection techniques, now you can see it has selected first a single features and found out the maximally performing here, and then it selected the two features, and then the 3 features, the 4 features, 5, and then finally the 6 features. Now you can see the accuracy here. Now the first feature, just one feature, the maximum accuracy is 77%, but with the 2 feature the accuracy has increased to the 96. With the 3 feature accuracy has increased to 98%, but as soon as it includes the 4 features the accuracy has decreased to 97%, but as soon as it increases to 5 features accuracy becomes the 99%, and then again if it is increasing the number of features, now accuracy is decreasing. And in the same way, what we can do now, we can go ahead and check with all the 13 features, and we can check how the accuracy is changing as it is adding the feature set. So with this example you can understand that it is not always the true that if you include the large number of the features then your accuracy will increase. There are a few subset of the feature which actually they perform better than all the set of the features. So this is the techniques of the feature selections which really proves it's important amongst the data scientists. Now you see I have included all the 13 features, but as it increases all the feature sets after the 7 are the 5 feature sets, now you see the accuracy is always being stuck at the 98 or 97%. So with this it proves that instead of adding all the features together, we have some techniques where we can actually reduce the subset of the total number of features, and we can improve the accuracy, and we can reduce the total training time. Now as you can see here, the training time for these features are really high, like 1 second or the 2 seconds. But now you see if it selects just 4 or 5 features, then accuracy the training time is around the very low actually. Okay, so this is how it is being done here. Now let's go ahead and see the total selected features, which features are selected in 13. Okay, that we can get with the SFS dot the key feature names. So it says that all the 13 features are selected. Why? Because I have given the upper limit of the 13 here. That's mean we want the 13 features. But with this we can say that we total want how many features? The 5 features. Now let's go ahead and do it with the 7, and then it will tell us how many features are there. Now you can see here it has trained it, and now you see it has just selected the feature set. Okay, and this says that this is the maximum 7 features, and in those 7 features it is selecting the maximum accuracy 99.32. Now let's go ahead and get the indexes of the features which it has selected, so that we can get from the SFS dot the K feature ID. So those feature indexes are 0, 2, 3, 4, 6, 9 and 11. Okay, and now let's go ahead and get the score with those 7 features, accuracy score, so that we can get with the just K underscore score. With this it says that the maximum score attained with the subset of the features is 99.32%. okay, now let's go ahead and see it in the form of the pandas data frame. That's mean how it is training, and throughout this training how the accuracy and the subset of the feature is changing. That we can get with the pd dot the data frame, and then we are going to create a data frame from a dictionary, and that dictionary is SFS dot get matrix dict, and then dot t. And with this what we get here, with this we get here in the first iteration it has selected the feature number 6, which is the feature name is this one. In the second iteration it selected this feature set and achieved the total accuracy of 96.52%. In the third step it selected this one, and similarly in the fourth step it selected this one, these features, and these are the indexes. And finally in the 7th step, so these are the feature sets and these are the indexes for the features. So this is really very helpful in the feature selections, and where you can understand the whole feature scenario, how the total features and their accuracy, errors, and total confidence intervals, standard deviations of the error and the standard error, etc. You can get and understand very wisely, and then finally based on this you can select the feature. With this we can find out that here the accuracy is maximum when it's selected in the 5th iteration, the 5 features, okay, in the 5th iteration. That's mean instead of selecting these 7 features, we can select just these 5 features, and with these 5 features we can get the maximum accuracy, which is 99.32%. Okay, perfect. Now let's go ahead and select these the 5 features here. Even after this, this is the visualization of the data, and with this what we are doing, manually we are selecting, but there are the techniques where we can select the maximum number of features, maximum number of features programmatically, okay, with the program. So let's go ahead and do this, and where we will select the programmatically, it will find all the combinations and then it will throw the best selected features. Okay, perfect. So with this what we can do, let's go ahead and copy this, press Ctrl and the C, and here I'm gonna paste it, and then here the key features, we are gonna put the key features. I'm gonna change it 1 to 8, let's say. Now it is going to find out all the combinations in between the feature 1 and 8. So it is gonna throw the 1, 2, 3, 4, 5, 6 and 8, and then it find out the best performing accuracy for these features. Okay, perfect. Now let's go ahead and run this. So once we run this, it will take a little time. Let's wait for this. Okay, so the training has been done here. With the training, now you see here the total 8 subset of the feature has been selected. Now since we have chosen that it will give us the best selected features in between 1 and 8, we don't need to select them manually, as I was telling here. Now let's go ahead and see what is the best K score. So here we have SFS, sequential feature selection, then .K score. It says that the best K score is 99.32. Okay, perfect. Now let's go ahead and get the SFS dot the K feature IDX feature names, the best actually the K features name, and those features are the 5 here. Earlier, you know, I told you that this is the feature set where we can select just 5 the feature subset, and similarly we are getting here those 5 feature subset, although we had selected here maximum number of feature set is 8. So with this method, this give us the best subset of the features. Okay, perfect. Now let's go ahead and implement now the step backward feature selection. Now with these feature selections, we have got these feature selections, and with this the maximum accuracy is 99.32. Perfect. Now let's go ahead and work with the step backward feature selection. Okay, which we can say here SBS. Now in SBS, what we need to do, we can just copy this, and once we copy and we paste it here, the same thing, it runs in the same way, but here the forward we need to make it the false. And what it is going to do now, it is going to find out the best possible features in between 1 and the 8 feature subset. There is just one difference, as I told you in the presentation, that instead of the feature 1, it the subset of the 1 feature, it will start with the subset of the all the features. That means it will first find the accuracy based on the all the 13 features, then on 12 features, then 11, and then 10, 9, 8, 7, etc. So now that means it will go into the backward directions and all other things will be the same. So with this, let's go ahead and run this and wait for some time to train it. Now the training has been done here. With this training, now you can see the first it has selected all the features, okay, and then it has started removing one feature after another. And then finally it comes to the 1 by 1 feature where the maximum maximum accuracy is the 77. Okay, so since we have selected here to find out the best possible subset of the features in between 1 and the 8 feature, let's go ahead and see which feature it has selected. So with this we can type here SBS. I think by mistake I have written here SFS, so let's go ahead with the SFS. Otherwise I can write here the SBS is equal to the SFS. And now let's go ahead with the SBS.K score. And now with this you see the same maximum accuracy whether we go with the forward selections or backward selection. There is just a difference. In forward selection it goes with from feature 1, and in the backward selection it starts from all the features. Now let's go ahead and see which are the features is selected by using the backward selection, and those feature names are here. Okay, so in the backward selection it has selected the 6 features actually. While working with the backward selection it has selected the 6 features, that's mean these features. Okay, so how it works, it starts from here, this end. Okay, so with the backward selection it has selected 6 features. So this is the way where you can actually understand which the type of the feature selections you want to select. So in the forward selection there were 5 features which were performing maximum, but with the step backward feature selection it has got the 6 features, subset of the 6 features. Okay, so this is the kind of the greedy the feature algorithm selections where it try to get the optimal solution. So sometimes we end up with the suboptimal solutions. Okay, perfect. Now let's go ahead and finally learn about the exhaustive feature selection. Okay, so this will be the final feature selection section in this lesson, and that is the exhaustive feature selection. Oops, sorry. Exhaustive feature selection, and that is the EFS. Okay, now with this what we need to do, we need to import the EFS from mlxtend library. So here we have from mlxtend dot feature selection import exhaustive feature selector as EFS. Okay, and then EFS is equal to EFS random forest classifier, and there we have n estimators is equal to 100, and then here we have a random state is equal to 0, and then we have here n jobs is equal to -1. Okay, and then finally here we have a minimum number of features. Since this is the exhaustive feature, here we need to select the minimum number of features from where we want to make the selection. So from 4, that means it will start all the possible combination from the subset of the 4 features to the maximum subset of the features, which we can select by passing the argument max features, where I'm gonna just pass here, let's say the 5. So it's gonna select all the feature combinations of the 4 and the 5, and then with the scoring here. Okay, and with the scoring is equal to we are gonna find accuracy, right? And then the CV, the cross validation, we want to do the 2 times of the cross validation. Otherwise let's go with the non cross validation. Why non cross validation? Since it is the exhaustive feature selection and this is going to take a lot of the time, really a lot of the time. I need to stop the video here and then I'll need to come back after an hour or the 2 hours to see it's a training time, because the exhaustive feature selection is the most expensive feature selection techniques. It takes a lot of the time. Now let's go ahead and select n jobs is equal to -1. That's mean utilize all available features, all available cores into the computer. And now let's go ahead and fit it. Now with this fit, what we can do, we can X train and Y train. Okay, now let's go ahead and run this, and once I run this, it's gonna take a lot of the time, because it is going to find out the combination of the 4 features and the 5 features. So with the permutations and the combinations, you can calculate how many subsets will be made with the 4 features out of the 13 features plus subset of the 5 features out of the 13 features. So it is kind of the NPR and the NCR problem. So let's wait for some time and let it complete its training. In fact, it might take hours to complete this the training. Okay, so meantime it has completed the training, and you see it has run 2002 times. Okay, and in meantime I have also calculated the permutation, I mean the total combination. So for the 4 feature, as we selected the minimum 4 features out of the 13 features, so there are total 715 combination of the features, and for 5 feature subset out of these 13 features, so there are total 1287. So if we sum this, we get total 2002 features. So while training with the exhaustive feature selection, the minimum subset with the 4 and the 5, it has trained for 2002 feature subsets. So with this, now you can imagine that if subset of the feature is high, then how much time it is gonna take to train, let's say, for 100 features. For 100 features there is 2 power 100 minus 1. That's mean in that case it is gonna take the forever time. So that's why the exhaustive feature selection is too complex. Okay, although this produces the best subset. Okay, and now let's go ahead, and if you want to know more about the EFS, you can type there the help and EFS, and then you can get a detailed documentation on the exhaustive feature selection for classification and the regression. And there are these are the parameters which you need to pass while training the exhaustive feature selection, and these are the parameters which it returns. Now let's go ahead and see these parameters, that's been the best accuracy find out by the exhaustive feature selection, and that we can get with the EFS. That is the exhaustive feature selection EFS dot the best score. With this we get the best score is the 1, that's mean with the 100% classification. That's really fantastic. Now let's go ahead, sorry, mistake. Now let's go ahead and get the best feature names which are the selected while working with the exhaustive feature selection. So these 4 subset of the features which has produced the maximum result. Okay, alcohol, malic acid, ACE, and alkanicity of the ACE. So with these selected features, you can get the maximum result if you select these subset of the feature, and the maximum result is the 1. Okay, now let's go ahead and see the indexes. EFS dot best IDX, and these are the indexes, that's mean 1, 2 and the 3. So these first 4 features is gonna perform the first 4 feature is going to give you the maximum result. Okay, perfect. Now let's go ahead and plot this, and you can plot this by using the plot SFS, although we need to import that plotting first. So from mlxtend dot plotting, import plot SFS, plot sequential feature selection as plot SFS. Okay, let's go ahead and plot it. EFS dot get metric dictionary, and the shaded area which I'm gonna put, that is the standard deviation, that the std underscore dev. Let's go ahead and see it into the plot. It says that there are 2002 times it has trained, and there are many times where it has got the maximum accuracy, okay, with the feature selection. Perfect. So this is the way how we do this training and the testing.